Okay, so we're going to start with some gameplay for the final sprint report. The controls are 1 to start 1 player, 2 to start 2 player. Okay, now that I've proven that the sound works, I'm going to shut that off because that is very annoying. You can shoot stuff, you get score. Alright. What else? The centipede, when it gets to the bottom, it does regular centipede stuff still. Looks like it should. Okay. I also have, if you hit plus on the numpad, you get 1,000 points, so I can rack up a high score. And subtract on numpad will kill you. Oops, you can hit that. There's a mushroom. No, I think that's it. Okay. And then subtract one more time. Oh, there we go. There it died. Enter your initials. You can hit backspace and get them away. Enter them in. Press enter to enter them. You can see in the top left my high score was 18,976. That's the second high score on the list. Press 2 for 2 player. Playing, getting some score. Oh no, I died. Note that the mushrooms are wiping and getting healed. Loads up the same mushroom field that it had, so pick a spot and memorize where the mushrooms are. I died. Now I'm back. Now I died again. The mushrooms are the same. 2. Let's see. I get a bunch of points here, and I get a bunch of points on this side as well as player 2. Ooh, I got a new high score. I died. Player 1 enters first. And player 2. And they both get entered into the list. I forgot to mention, if you, let's go into 2-player mode. If you hit backslash, it will trigger up the next wave. You can see this one has 2 heads. And then if I die, the player 2 is still on the first wave with 0 solo heads. If I die again, player 1 still has the 2 heads. There we go. Game over. Okay, let's start looking at some design patterns. We have the blaster has strategy, I call it controller. Movement controller, which is set in the initialize, set to keyboard movement or AI movement. Then in the update, it just calls movement controller dot, it points to get velocity, which is defined in a superclass. That didn't work well. Defined in the superclass for movement controller, and then extended by AI movement controller into its get velocity, and keyboard movement controller and its get velocity. And those do different things to get the velocity. AI controller just keeps moving until it hits an edge. Keyboard is based off of the keyboard input. other strategy patterns were the one I was most proud of was for the HUD. In the HUD I have I broke it up into draw left score, draw right score, draw high score, draw left lives, right lives, attract mode, which is the high score list, and score entering mode, which is the great score, enter your initials words. And those are all called from the HUD strategy, which just has a draw method, which is called every frame by the HUD manager. Let's take a look at 2-player. So 2-player draws the left lives, left score, left lives, right score, right lives, high score. Whereas, let's see, attract mode does left score, right score, high score, attract mode. So no lives, and now it's drawing the attract mode. And all these are they just iterate through. They call draw symbols on the list of symbols, so it's a list of glyphs. And draw symbols just iterates through. And I have that for each of these in the score entering, attract mode, 1-player and 2-player mode. Another strategy pattern I did was for the sound manager. I have a sound strategy muted, which has a bunch of methods that do nothing, and then a sound strategy on, which loads in the sounds, and then when it calls, these ones actually play, when it calls, say, play Blaster Fire Sound, it actually plays the sound. So then in the sound manager, it's a call to, say, play Blaster Fire Sound, and calls the current sound strategies version of that method, which will either play it or not play it. I have a lot of observer patterns all over the place for things. A good example is the wave manager, which has spider died callback, scorpion died callback, centipede, flea, mushroom, blaster, and all of those do appropriate things. So the flea tells the wave manager that there's no longer a flea on the screen, checks the mushroom number again to see if it should spawn a new one. The scorpion one sets up the alarm for the to get the next scorpion going. Mushroom checks the mushroom number for to check if a flea should spawn. Lost my place, sorry. Blaster does a bunch of blaster logic, or reset, it kills all the things, and then so it triggers another observer in the player manager. So I have a lot of those around. In terms of factories, we'll take a look at the centipede factory, which has create centipede chain, given starting position, number of segments to put in it, and centipede speed. And you'll see that that calls create centipede, which creates the specific segments. And I'm doing instance recycling on that. On almost all my factories I think all of them I have instance recycling. At the end here, I'm adding it to an active items list. This is the one the entity that was just created. Now I have a destroy all, which goes through the creates a copy of the active items so it can destroy them and not worry about editing the list as it goes, and marks them all for destroy, and then clears them, or it clears the list. So that's called it's called in reset wave, along with a lot of other ones, I'm pretty sure. Reset wave, yep, all these destroy alls. They're all factories, clears all the everything on the screen. so that no more enemies are on the screen. And for singletons, check out the managers filter. They have a game manager, HUD manager, player manager, sound manager, wave manager. They're all singletons. Within the mushroom filter, the mushroom field I have implemented as a singleton as well. This guy here, standard get instance blah blah blah, and a bunch of public static methods for adding things, removing things, checking general things about the field, clearing the field, doing all that. And then here, these two, the get mushroom location list and load mushroom location list. Those are called from the player manager, I think. And what those will do is those will get all the locations of mushrooms on the current field, put those locations into a list and return it, and then the player manager, actually let's take a look at that. The player manager will save that to the current player. Nope, not that one. Nope, nope. Here. Oh yeah. I had to implement this as a enum with a switch statement because I couldn't think of a quick way to get this as a strategy pattern. So when this says player death, it's when the blaster dies. Then this deals with all the player logic. One player does that. It'll one player doesn't do it. Two player. This is what I want to look at. It will get the current player, then sets their list to the current list from the mushroom field. We'll take a look at the player as well. Player. Player I have as a class with just a bunch of getters and setters, pretty much. This, most importantly, it's storing the lives, the score, the wave number, the player type that's either human or AI, the list of mushroom locations so that it can load up the right mushroom field, and the and a temporary variable for how many mushrooms have been counted during the wipe, so it can do the proper 5 points for every 2. And my mushroom field is contains mushroomoids, which have a couple of things that are called from the mushroom field, and that's extended by the blank square and the mushroom classes. Blank square doesn't do much. This is what I use behind the text, so that the text still has collision stuff with the centipede. So it'll still, the mushroom field will say that there's something there. For the centipede, I have all the centipede segments as just the centipede class. I don't have a subclass base class thing going on. I have a structure orientation, so it's position, the theta for which way it's facing, so that the x direction, which is where it goes forward, and the y direction, which is when it goes to a turn, will it turn up or will it turn down. The centipede update method checks the queue of orientations. If it's empty, it will generate a new one. And so orientation equals turn or go forward. Each of these will generate a new orientation given the current orientation. If the queue has something, it will use that as the current orientation and pop it off the queue. Now that it has that orientation, either from generating it or getting it from the queue, it will push it back to the one behind it, if there is one behind it, then sets the sprite up so that it draws at the correct position. So I didn't have enough time to make it so that the centipede was generating a bunch of frames in advance, but I do have it so that it's doing the rotation just based off of a rotational speed around, and it's like orbiting an actual point. But I'm not doing the trig every frame, and I'm doing that by this setup turn offsets method, which will generate a big table of a bunch of trig values. So it'll generate a table of a bunch of offsets of just trig values, so from 0 to 1, and these will go in order through a half turn. And then when I set up the turn, I can pick whether to flip it vertically and iterate through the list bottom to top. That would do the same turn going up, so once it reverses at the bottom, it'll do that. Or I can reverse just the cosine value, and that will give you a turn going the other way. So when you're turning the other way, from one trig list, I get turns out of it. I was pretty happy when I got that to all work. And those factors are set up in the setup turn function, depending on the way you're facing and all that's the cosine charge and delta turning frame. I called it delta turning frame because turning frame is the current frame or index in that list, and the delta is added to it at every frame. Here's a look at my look ahead function for the centipede. I called it should turn around. It gets the grid coordinates, moves it one ahead in the direction it's facing. Then it calls to the mushroom field and tries to get a mushroom at those coordinates. And the mushroom field will either be null or an actual mushroom, or a mushroomoid technically, because it could be a blank square. And then if it exists, it tests if it's poison, does that, and that'll return true. And if it didn't get a mushroom from the mushroom field, it will also check if that position is outside the screen or outside the field. And if it is outside the field, then it will turn around anyway. If it didn't get a mushroom at the point and didn't get outside the field, then it'll didn't get outside the field, then it turned. Looking again at the mushroom field, we have the generate mushrooms, which is called by priv generate mushrooms is called by generate mushrooms, which is called at the or priv is called at the end of the constructor, and generate mushrooms is called when they switch to one player mode, or you switch to 2-player, and on the second player you need a new field. So generate mushrooms goes through the field, generates a random number, and checks if that's within the spawn percent, which is 5 apparently, which I've set in this file, and then it calls add, if it is within that percentage, it'll call add mushroom at that point, and then add mushroom, check if there's a mushroom already there, or check if something's already there, and we'll try to make something there, and sets the pointer, and then increments the flea mushroom count, which is checked by the wave manager when it does check mushroom number. So we'll get the flea count if it's below the threshold, which is set by the wave values file. And if there's no flea on the screen, it will spawn a new flea. In the wave manager, take a look at where I'm reading in the wave values. So this is in resources wave values.txt. While you're not at the end of the file, read until you hit start. Then it's reading in all the integers first. So if it's reading in integers, push the whole row. Oh, no, what am I doing here? Oh, okay, so this is a start. So int values is a vector of vectors of ints. So int values will hold the all the integer values, so the number of centipede segments, the number of things for the flea to wait on, and those could be any length. Those could be this file. It's easier to look at it. Yeah. So start with all the integers, then all points, just for convenience of reading it in. And so I'll have a vector of with each entry in the integer vector will first one will be centipede, the second one will be third one will be centipede speed. Then each of those entries will themselves be a vector, and those will hold the numbers, so 12, 5, 10, blah blah blah. Then in the second one, so this would be like entry 2, 0 would be 0, entry 2, 1, or 1, 1 would be 1. Hope that makes sense. So I'm pushing back the row for, say, number of centipede heads. And then, while true, read until you get to the word end. And if you're in integers mode, push back the integer version of the thing on the row. And then if you've read in end ints, switch out of integer mode. So what I like about this method was I can make these lists any length I want, and I don't have to know how long they are beforehand, because they're vectors, so you can just, they size themselves and it's all nice, but I can still index them. So I can say get the 6th one in centipede head number. So I'm reading those all into int values and float values. And let's, if I can open up the manager. We'll see, okay, so for int types, a bunch of enums, value types, a bunch of enums, I've coded these to the indices that they will be in the vector. So this has to correlate to the text file, which would be easy to screw up, but again, it makes the reading a lot easier. So I have a get value for wave, which takes in an int value type or a float value type. So when you call it, it's a similar call and a wave number, and then it'll get that information from either the int values or the float values vectors. And if you're trying to get one that you don't have yet, that is greater than the size, it'll give you the last one. Okay, we're going to go down the rabbit hole for a bit here, walk through some of the logic. So in the wave manager, let's say the blaster dies. So this could be in attract mode, this could be in gameplay mode, whichever. What we'll do is reset wave. That will kill all the enemies and all the bullets as well. So that clears all the moving stuff from the screen. Then it calls player died, call back in the player manager. Let me hop over here. So player manager, and I showed this a bit before. And so it's set up for 1 player, 2 player, or AI player modes. That's set up beforehand. So the blaster just died. And we need to check what to do, whether to reload the field, whether to respawn at all, whether to check for high scores. So we check if we have more lives. If we have more lives, then decrement the lives. Clear the mushroom count, which I do with healing mushrooms. And then I'm calling heal all mushrooms, passing in load mushroom field and is game over. So load mushroom field would tell it to load a new mushroom field. So on 1 player mode and attract mode, this will always be false. Is game over tells it whether to spawn a new blaster or whether to check for high scores and then exit out to attract mode. So we'll see here 1 player, if it has enough lives to spawn a new one, it will not generate a new mushroom field and not end the game. If it doesn't have enough lives, it will not generate a new mushroom field, but it will end the game. 2 player, first off, we set off the mushroom field location list to the player, swap players, so that changes what current player points to. Now, if that new prospective player has enough lives, then decrement, do the heal. Now we are loading a new mushroom field because this is for the second player, so we will try to load their mushroom field. And we're not game over because we have enough lives. Else, if we switch players, or we try to switch players and they don't have enough lives, recheck if the old player has enough lives. So then swap back, decrement, save off the thing, load a new mushroom field, not end the game. Double else, if nobody has enough lives, then heal all the mushrooms, don't load a new mushroom field, and it is game over. AI player, heal all the mushrooms, don't load a new field, never game over. Every time the blaster dies on AI mode, you never load in a new field and never end the game. Okay, so that's a setup. Heal all mushrooms. 1 level deeper. Heal all mushrooms is called once, right when blaster dies. So we set up some variables, mushroom heal X, mushroom heal Y. So this is for iterating through, and save off those variables that we passed in, because those will be used later. And then we call heal callback. What heal callback does, this is where I'm wiping through. So I'm iterating through, and if there's a mushroom or mushroomoid at that location, then I heal. Look at the mushrooms. The mushrooms heal will reset its sprite, reset the to come on. There. Yeah, that. And if it doesn't heal, it returns false. If it did heal it, so if it needed healing, it creates a heal explosion, which is the little animation, and it sets alarm 0 for the duration, and then it returns true. Let's look at alarm 0. Alarm 0 just calls heal callback in the mushroom field. If you go back to mushroom field, that heal returns true if it did heal, false if it didn't heal. So true if the alarm was set, false if the alarm was not set. If the alarm was set, increment these counters, or else these won't get incremented. and then we exit out of this function entirely. So now that alarm is getting incremented over in the mushroom, but nothing is happening over here in the mushroom field until that alarm goes off and it calls heal callback again. Now mushroom heal x and mushroom heal y are instance variables for the mushroom field, so those won't get reset. Those stay where they are. And if you remember, the last thing we did was increment them one past, or we increment them, well, that's incorrect. This should just be, this line should be here. It should be incrementing the y. We increment and re-enter right back where we were. So then it'll go through and it'll heal all the rest of them. And if one of those gets healed, then it'll set the alarm and return early again, wait for the alarm to call back, start the callback, return to where it was, keep iterating through. We get to the end. Oh, and you have to reset heal down here because I don't want to set it up in a for loop, because when you come in, you could be coming in at any point. So once we've iterated through all of them, and this could be after multiple callbacks, multiple alarms, now it's checking those variables that we set right at the beginning when we called heal all the mushrooms. So if it's game over, we go to the game manager, which is a top level thing, game over. If it's not game over, we load and then start the next wave, which is back in the wave manager. Alright, go on. Now let's look at the game manager. So this is mostly just for organization. I made it a singleton just in case I ever needed to store any state data or data up in the game manager for some reason, but I never actually used it. So this has a bunch of things like start a track mode and a long list of calls to all the managers in the field to set everything up. Start gameplay, along with all the things that do. Two-player gameplay, a bunch of things it needs to do. Game over. Okay, let's look at this. Game over. We'll check for player 1 high score and switch to score entering mode in the HUD manager. Switch to score entering mode. Gets the changes the strategy to score entering mode and creates a new initials controller, and it calls setup scoring mode, which sets up the list of symbols. The initials controller is a game object. A game object that this is, most of it's the text entered in the key press. Yeah. This is instantiated when you're entering in score your initials for the high score. So the text entered, I filter it down to the alphabet characters and then add the right stuff. I was able to correct for the lowercase, uppercase difference. And then back and return, call remove and end initials. This add initial is back in the HUD manager. Passes in a char. I'm adding this to a stack of glyphs. So as long as you have room, add it to the stack, and then create a blank square under that letter, and then one to the one unit to the right, just to make sure the spaces between the letters are even, and then each of these initials is spaced 2 over. So it's doing that, and then when you hit enter in that initials controller, it calls end initials, which only works if you've entered in the right number of initials, and gets all those, turns it into a string, tells the player manager to write a new high score, and writing a new high score, so we know that it's this is called when you know that it's going to be a high score. So you get the high score of the player, and you have to get it from you have to pass in which player you're getting, because it could be at the end of 2-player mode, so you can't just use current player. So you have to get that, because it could be calling both of them at the end. Opens the file, and now it's iterates through the list of scores and the initial at the same time, and also capping it at the number of scores, because if you after you add this in, you'll have one too many. And checks if this score that you're adding, this current high score, is bigger than the one you're looking at. If it is, add it in before the one you're looking at, then add in the one you're looking at, then do the rest of them. Close the thing, read in the high scores, make sure that everything does, so that the next time the high scores are displayed, everything's set correctly. So once that's all said and done, this will so if you came in as player 1, now you should check as player 2 and see if they've scored a new score. So this is again at the end of 2-player mode. And after you're done with that, then you can sit back to attract mode. I think that was the end of line plot. The HUD manager, the main way I'm doing HUD stuff, so we'll start with setup attract mode, or priv setup attract mode. If this will go through all the lines on the screen, so score label text, scores, more records, credits, let's set credits to bonus text, bonus, whatever, blah blah blah, which are strings. It creates the glyphs for those to lists and at the right positions. So then later, when you're calling like draw symbols, you pass in whatever list you want to draw, and it'll iterate through that list and draw them. So that way you're not generating the glyphs every time. You have to do setup attract mode or setup scoring mode, and you're good. Of course, all over the place, I'm using constants instead of magic numbers. So for example, in the HUD manager, I'm defining a bunch of constants. They should be in all caps, so whenever you see those, that's a constant defined somewhere. The I didn't use for setting up everything in the HUD manager. Everything is centered dynamically, but the row that's on is still a number. I thought that would be reasonable, since those numbers are only read in, or they're only put once. The designer really wanted to change those. You could change those right there. Other than that, everything else is a constant. And again, the keys to control it are 1 for gameplay mode, for 1-player mode, 2 for 2-player mode, plus on the numpad will add 1,000 points, subtract on the numpad will kill the blaster and lose your life and everything that entails. Backslash will increase the wave number without killing the blaster. Entering initials, type in the initials and hit enter. Backspace will let you take initials off. And that should be all the keys you need.